Hi, I'm an old guy and I do maths. Today we're looking at the idea of standard deviations. We're not going to calculate them, that's the subject of a separate video. You may indeed never have to calculate them by hand, which is what the separate video informs you about. Most of the time you'll be doing this on a calculator, but you do need to understand what standard deviations are and how they work. So what we have here is we have a bell curve, which is the graph of normal distribution of some data, and hopefully by now you know that such a normal distribution is split in the middle by its mean, and that 50% of all data in the data set sits over this side of the mean and 50% sits here. Now that's useful, but there's more information that you can get from this. You can break each side of a bell curve up into smaller areas. Now, I apologize, this is not to scale. Now what I've done is I've drawn in 3 notional standard deviations. Now a standard deviation is a measure that's calculated of a distance from the mean, either positive or negative. So this is 1 standard deviation in a positive direction from the mean. This is 2 standard deviations. This is 3. This is -1, -2, and -3 standard deviations from the mean. Now, they are usually characterized by numerical values calculated using the range and the data. They're a measure of range. They can be referred to as 1 standard deviation from the mean, but you'll also get a numerical value calculated, and you'll usually see it along the graph somewhere. That's not our business today. Our business today is simply to understand a little bit about what these do, not how you calculate them. Right. So what do? Well, they break up the data into more manageable and understandable groupings. It's as simple as that. And they give us an idea of how far from the mean, the average, a particular piece of data is. So if a piece of data is 3 standard deviations from the mean, it's either up here or it's down here. Now, given that the scale on what we might refer to as the y-axis of this graph is runs from not likely to more likely. So this is a measure of probability. Something that's 3 standard deviations in either direction from the mean is a kind of unlikely piece of data. So if we take the example of height, someone who is in the middle of their high school career and is 2 meters tall, getting on for 6'6" or so, is likely to be up here. And I think you would agree is in the category of unlikely. Most people will be centered around the average. This is where you see the big grouping of people for things like height. Okay, so let's take this 1 step further. At the start of this video, you would have seen some numbers to the right of standard deviations, 68, 95, and 99.7%. What those numbers represent is they represent the percentage of data that falls within particular standard deviations. So 1 standard deviation either side of the mean captures 68% of all the data in a normal distribution. So if we go back to the example of height, and we take good-sized sample, like an entire school, what you would find is that having calculated the average, assuming that height is normally distributed, 68% of people in that surveyed group would fit within one standard deviation of the average height of pupils at that school. Now, as I say, how you calculate the numerical value of that standard deviation is the subject of another video, if you need to know how to do it manually. If you don't need to know how to do it manually, it's a function on most graphics calculators. It's simply a matter of entering the data and asking your calculator to find a standard deviation, which means that, so for instance, just by way of a wild example, if we say that the mean height is 170 centimeters, and you put in all the data and you get told that a standard deviation is 10 centimeters, if this measurement here is 170, this will be 180, and this will be 160. And that's how you note the numerical values of these things. So what can I say to sort of give an overarching idea of what a standard deviation is? It's a measure of range. If the numbers here and here are far apart, the standard deviations will get wider. If the bell curve looks a little bit like this, the standard deviations will be quite narrow. So they are a measure of range. Now, let's see how the rest of this operates. So we would expect 34% of all data to fall here and 34% to fall here. This is where we get the 68% rule from. 68% of data would be expected to fall within one standard deviation of the mean in a normal distribution. If we go out another standard deviation, we can add 13.5%, that's a percent, to either side here, and what we'll wind up with is capturing 95% of our data within two standard deviations of the mean, which would mean, if we go back to, again, the example of height in a school, you'd expect 95% of pupils to be, their height to be within two standard deviations of the average height of pupils in that school. So, if the average height of pupils in that school is 170 centimeters and the standard deviation is 10, two standard deviations would put that at 170 plus 10 plus 10, 190. And in this direction, 170 minus 10 minus 10, 150. You would expect 95% of pupils to be between the height of 150 and 190 centimeters, which, for those of you versed in metrics, if you think about that, that is not an unreasonable outcome. You might get the unusually tall out here and the unusually short here, but you'll get 95% of the pupils within two standard deviations of this mean. If you go out a further standard deviation, you'll capture nearly everybody. There are further standard deviations out here, but usually we deal in the first three because it captures so much of the data in a normal distribution. So, that's really all I wanted to say about this. What will happen next is there's a video in the playlist about how to calculate a standard deviation. You can bypass that if you're using a calculator to do it. And there will also be a couple of videos involving standard deviation problems and how it is that you can use standard deviations to come up with some useful information about the data in a normal distribution. Anyway, thanks for watching this. I hope it was informative, and I will see you next time. Bye.